In other years, I would have gone ahead and done this example, and actually last year's video, if you go looking around the same time of year, in 2017, you can go find that example if you think you need it. But let's go ahead and play around with the other highlighted box of formulas, the half-angle formulas. Let's go play around with the other formulas that we have, the half-angle formulas. Because I want you guys to see, because this will be on Tuesday, and it will be in your homework, and it does get tricky with this watch out. Anytime you see watch out, right? Anytime you see watch out, you got to be careful. So, what's about the watch, or what's going on with the watch out? In the formulas, do you guys see, you're writing them right now, right? In the formulas, do you see the plus or minus with sine and cosine? Oh, we did that. We did that with square roots. Remember, like absolute value, oh, it could be a plus or minus. We did that. And we kept it plus minus if they didn't tell us constraints or conditions or particulars. But here's the struggle. If it's a particular place or value, isn't it going to be either positive or negative? Right? Trig is going to have a sign, positive or negative, if it's like definitive, if it's in a certain quadrant, if it's of a certain angle. So here's the struggle. The formula says, I don't know, plus or minus, you figure it out. How do we figure it out? Based on the info given, that's so general and vague. What does that mean? This just says you should be able to do it. Great. How? Well, let's do one. Sine of 105. Isn't that 90 plus 15? It's not 90 plus 30. We have like our 90, and then we have like our plus 30 and plus 45 and plus 60, and then, so this guy's right here? Haven't you seen some impossible to use with the unit circle values, like over 12s that you've been able to do when you split it up with the unit circle? Even though we don't know what 105 is, guess what we do know? We know 210. What? How does that help? What's 210 over 2? Oh. So I can find sine of 105 by seeing him as 210 over 2. Guess who 210 is? Isn't that 180 plus 30? Isn't that 7 pi over 6? We know 210. 210 is 7 pi over 6. So we can use 210 to get to 105 exactly is how the homework would say it. And Adam, I think you and I were talking about exactly. Exactly means no decimal places, no rounding, because as soon as you round, you bring in error. So leave the radical 7, or wasn't that one of them? Leave the radicals, just leave them there, just like we did in class. So we can't do sine of 105, but we can do sine of 210 over 2, which is 105. Go team, but we have to use the formula. And the formula says, oh, if you just memorize the formula and you just write what you see on the formula sheet on Tuesday, you'll put a plus or minus, and then you'll be like, okay, let's go. 1 minus cosine of who? Well, of u. And who's u in our example? Yeah, cosine of 210, or 7 pi over 6, all over 2. What is cosine of a pi over 6? 1, 2, 3, 3. 3 is a pi over 6. So square root of 3 over 2. 1 minus. Now we could make this a little bit prettier by doing my nifty-difty complex fraction trick. If I distribute the 2, I get 2 minus. I distribute the 2, I get root 3. And 2 times 2 is 4. Actually, you guys are like, oh, I have to rationalize that. But wait, doesn't one big square root just turn into 2 little square roots? Don't we know square root of 4? Isn't that just 2? Now that top, that numerator, no thank you. We're going to leave that numerator just as it is because the square root of, we actually can't simplify him anymore. Because I can't just distribute a square root, just like I can't distribute a sin or an ln or anything else. I can only distribute multiplication. But I can write it like that and say that's exactly right. And it is, except, what have I not done? When I wrote this, I was just following the formula. But don't I have a specific angle in mind with a specific location? And that specific location is in what quadrant? And what sign, S-I-G-N, positive or negative, must sign have in the second quadrant to be right? All students. My right answer is the positive 2 minus root 3. The negative one was illegal for this problem. But in another problem, couldn't I be in the third quadrant and I need to cross off the positive and keep the negative? So you have to choose the sign based on what you know. Robbie?
So would the negative be an extraneous solution?
Yes. You can think of it that way. Okay, we have practiced at least something to do with. Now, some of these we're using triangles, which is good practice. Some of these we're using like just trying to make it look like something with the first degree, kind of like just transforming. Some of these we're actually solving and evaluating, but it's impossible unless you use a formula. I want to do one more example before we transition into grading. And that one last example is going to be, well, you guys know what this is going to need, right? Triangle, because I have an opposite over adjacent. Do you guys recognize the type of problem yet? It's going to be a 5, 12, 13 triangle. You're going to put it in the right quadrant and find what you need. Anyway, can we just go to some random page? Some random page. Here we go. Let's go to some random page. Because we have these random formulas. Go to some random page. We have these random formulas and see if we can figure out how to use them. Because maybe, just maybe, on the test on Tuesday, you're going to have something where you need to use a formula and it might not be one of the ones you had to memorize. Does that make sense? It might not be one of the ones you had to memorize. I still need to make sure you know how to use it. So we haven't done one of these today. Let's end here as far as our notes. Okay? Once again, if you need to or if you want to, you can go ahead and go to 2017, beginning of December, and find where I covered section 5.5. If it was in December, you guys might have actually made it one section past last year. You might need to go to their January. Anyway, there will be a video from last year, either December or January, section 5.5, and see as many examples as you want. But for right now, we know how to read these directions, right? Aren't you going to the unit circle? But you can't go to the unit circle until you... I need the trig to be alone. I think I need to transform some stuff. What do you guys think? Are we transforming the one? No. What should we go transforming? Okay. Do we have a formula for this guy? P.S. Look at the very beginning of section 5.5. The answer is yes. The double angle of cosine. We have 3 different formulas. Do any of them look like they would help us with getting rid of what's on the bottom of that fraction? Cosine squared minus sine squared. 1 minus 2 sine squared. 2 cosine squared minus 1. Do any of them match up with this guy? Who is that guy? Is that a sum and difference formula? No, because I need sine, cosine, cosine, sine, right? It's not a sum and difference formula. Do any of these formulas look like one of these where you have sine of u and sine of v? Let's check it out. Sine of u. You're going to have a formula sheet on Tuesday. So if you have somebody that you don't like in either a t-proof or in an equation, can't you go to your formulas and be like, I need to change him? I need to, wait, which one was he? Minus. I need to change him, and you'll have your formula sheet to change him. Now, will you always know exactly what you're changing him into? No, you don't have him memorized, but you can use the formula. Can you guys help me out? It's cosine, then sine, plus, then minus. You got that straight? Cosine, then sine, plus, then minus. I can rewrite this bottom to be cosine, then sine. You'll have these formulas. You don't have to memorize them. It was plus, then minus, right? 3x plus x over 2 and 3x minus x over 2. That didn't help at all. Wait. Did that make all the difference? What's 3x plus 1x? What's 4x over 2? That helped. And this is an equation, right? So can't I do 1 over sine of 3x minus x is 2x. 2x over 2 is just 1x, right? Minus 1 equals 0. Kyle up here is like, that's cosecant. But couldn't you even be snazzier? Couldn't you add the 1 if you don't like the way it looks? Not even make it cosecant? And couldn't you multiply up by sine? You could think of cosecant if you really, really want to. Most people, that's harder though. Wouldn't it be easier to think of when is sine 1? Cheater chart. 1, 2. No, that's 1/2. That's 1/2. That's not 1. Remember, isn't sine the x or the y? So we're looking at, Adam's already jumped there, Kyle was jumping there. We're looking for when the y is 1, which happens at pi over 2, and at, not negative pi over 2. Wait, what's my interval? Oh, I can't even go any farther. I can't even go any farther. Forget it. I only have one answer. And the one answer is pi over. Do you guys see what I did, though? I thought of my double angle. Oh, I see it. I see it. Should I just automatically start using it? No, look and see if it helps. Remember from T-proofs how we were looking to the other side to try to guide our direction or our steps? Does that make sense? So, on Tuesday, what are you going to have? Problems to do. From 5.1, 5.2, 5.3 type problems, which you were practicing in 5.4 and 5.5. But what are you going to have to reference? A formula sheet. So wouldn't it be a smart idea this weekend when you're doing 5.5 / starting on the review to write out your formulas on a formula sheet, which will be so much faster than flipping back and forth in your notes. And then couldn't you also have said formula sheet to be studying? Studying all of them? No, only the ones that are highlighted. You guys mark them in your notes? Okay, we're going to go grade. Lacey, if you need to, get out of here. We're going to go ahead and go grade. Yes, there were more examples. Wait a minute. Does this look like cosine U, cosine V? Oh, that looks disgusting. Maybe there's something else that lets us take... Oh, it looks kind of like this one. Where maybe we can take a plus and we can make it a times. Anyway, do you see how there are different ways of using it? We're going to go ahead and grade, not section 5.5. This is what we're looking at on Monday to see how you did when you had the formulas in front of you. But I just needed to impress on you the idea of you have to formulas I told you memorized by then as well. All right, kiddos, look at your homework spirals. I heard a rumble, a rumor, that maybe we didn't grade section 5.3. Can someone back that up? Did we grade section 5.3 at all? All right, so let's go to section 5.3 first of all. Then we'll go to section 5.4 and see what questions you had. But let's first of all get at least all of our evens graded. Okay? So we're going first to section 5.3. The book is looking for it, and the answers should be popping up. Hopefully all in good time. And yes, I'm multitasking just a little bit and getting calculus BC stuff ready. Okay, here we go. Well, that's not helpful. Here we go. Okay, section 5.3. Number 4 was extraneous. Ooh, that word came back. Number 14, you were solving for all. Wait a minute, no, they wrote 2n pi. We wrote 2 pi n. It's the same thing, same thing, same thing, same thing. However, I think Kathleen might have written this. No, that wouldn't have worked. I was thinking plus or minus, but that's only for cosine inverse. It doesn't work for sine, sadly. 7 pi over 6 plus 2 pi n, or 11 pi over 6 plus 2 pi n. I think Austin and Gavin, you were asking, this cannot be pi n because they're not 180 apart. One's third quadrant, one's fourth quadrant, and then Kathleen, your plus or minus doesn't work because similar logic. Number 20, plus or minus. Look, it's important because we have more answers as a result. But this guy Check it. It was pi n before dividing. Tangent inverse of both sides, square root of 3 over 3, 1 square root of 3. Happens at pi over 3's plus pi n to get all the quadrants. And happens at 2 pi over 3 plus pi n to get all the quadrants. However, you had to divide by 3 to finish this off. But I wanted to show you the plus pi n was because of the tangent. The plus or minus said all quadrants are acceptable. That's why we have so many answers. Number 20, you had to make that sine squared, 1 minus cosine squared, move it all to one side, factor. Ooh, it wasn't even a trinomial. Look at you guys, spoiled rotten. Factor set equal to 0, solve, solve, solve. There they all are. 1 is x, 0. Pi over 2, 3 pi over 2. 1 is cosine negative 1/2. 1, 2, 3, 3, 2, 1. 1 happens at pi over 3. Booyah, but negative. Number 36. Looked an awful lot like some t-proofs we've seen. Sine over cosine, common denominator, 1 over cosine. You can either say that secant and have to think real hard, or multiply up cosine and divide and not think so hard. Positive, first quadrant and fourth quadrant. Number 40. Is anybody having a little bit of issues with when there's like a 2 or a 3 inside? Yeah, I had a few people after school, and so if they're having questions, I'm guessing you guys are too. Whenever there's a 2 or 3 inside, let me just quickly show my work, because this very well could be one of your homework questions. When there's a 2 or 3 on the inside, you just can't go dividing yet. That's so illegal, it's stuck. So you have to undo the sign first. And what you do to one side, you do to the other. I think I heard Kathleen explain this to someone after I'd explained it to her. When you do that sign inverse, you're not just looking for one answer, because they say find all. You're not just looking for one. But you do need to ask yourself the question, when is sine negative root 3 over 2? Well, sine is negative in this quadrant and that quadrant. 1, 2, 3 at the pi over 3's, which is why they're using 4 pi over 3 and 5 pi over 3. But that still equals 2x. So now is the time to multiply both sides by 1/2 to get rid of that 2. But you can't divide by 2 until you get rid of sine, which you can only do by using the inverse to go backwards. Is unit circle backwards important? Yes. Oh, yes. 60, quadratic formula, ends up being nasty. It's not unit circle. 3 over 3, 1 square root of 3. And they had to use that nifty trick of graphing tangent and graphing the value and finding the intersections. You guys can see them right up here. Graphing tangent, graphing the values, and then finding the intersection. I talked about that in class that one day. Number 86, you were just looking. You didn't even have to find the numbers. They say, how many times will they be equal? Or how many solutions will they have? Just look at the intersections, and there were 3 of them. So the answer is 3. Number 94, sorry guys, the pi's got cut off. That's a pi, and that's a pi. This one was an application problem. Man, these Ferris wheels, they just keep on coming back. The application is, that's the sinusoidal axis. The middle of the Ferris wheel is 53, I think, feet off the ground. However, the actual Ferris wheel only has a diameter, no, not diameter, sorry, a radius of 50, because it goes up 50 from that center point and down 50. It has a diameter of 100, technically, a radius of 50. You could have pulled out your pi over 16 if you wanted to get your period. They were asking, when will the person be 53 feet above ground? When will you be passing the center of the Ferris wheel is what they basically were asking. So long story short, you just had to set this guy equal to 53, subtract the 53 is 0, divide the 50. You're just trying to get to t. Sine inverse both sides. Sine inverse of 0 is 0, or pi, or 2 pi, or 3 pi. So they went ahead and just solved by subtracting, and then dividing, and then sine inversing, getting 0, and then pi, etc. And then at that point, once they had some answers from the sine inverse, just add and multiply by the reciprocal. Just add and multiply by the reciprocal. Pi over 2 times 16 over pi is 8. And 3 pi over 2 times 16 over pi is 24. Technically seconds. When are they at the top? You can do this a couple different ways. I think the easiest way would be either to say, when does the sine thing equal positive 1? That's the highest it can be. The other way is they'll be at the top when their height is 103. Because you would have the full diameter and the extra 3 feet off the ground. So you could also set the height equal to 103. You get 16 seconds. If it happens every 16 seconds, they were trying to talk about when this will occur. They found the period by doing 2 pi over b. The period's every 32 seconds. So 16 seconds, it'll be right back there, another 32 seconds, which is why they just said plus 32, plus 32, plus 32, plus 32. Because they were able to add the period and shortcut the work. They were able to add the period and shortcut the work. I think that's it for section 5.3. Let's go grade the evens to 5.4. Let's go grade the evens to 5.4. Quick word to the wise for the test on Tuesday. Word problems are not exactly the main emphasis of the test. Every now and then you see them in homework, but they're not the main emphasis of the test. What's the main emphasis of the test? Transforming T-proofs and solving. And in solving, you have getting trig alone and using the unit circle and inverse trig backwards. You also have the idea of using triangles, given sides, finding the missing side, and then answering what you're being asked. There are a few other types of special applications, but word problems are not the focus. 1 and 2 and 3 and 4 and 5 and 6, we're just plugging in formulas. Think I was trying to make you study? Number 14 was a plug and chug. Why are the answers so gross? Because they said, Adam, what was the key word? Leave it exact. Find the exact value. So leave these little radicals. Leave it. Don't do a decimal. Leave it. Plug into your formulas and then leave it. Some of you guys might have done like root 6 over 4 plus root 2 over 4. That's good. Root 6 plus root 2. That's right. That's not wrong. Some of you guys would have done root 2 minus root 6 over 4. That's right. They just simplified them in a few different ways. Number 30 was one of those where it was like, oh, I can't do that. It's a property backwards. Yeah, I can. Now, don't solve it because you don't know what the answer is. You have to do the exact value, and that's not unit circle, but it's a whole lot easier than it was when you started. Same thing with number 36. Sometimes you can do formulas backwards, and they make life so much easier. On Tuesday, sometimes you'll be going forwards with the formula and sometimes backwards. So when you're looking at your sheet of formulas on Tuesday, think forwards and backwards for trying to find something that makes the problem easier. This one, though, we were able to do because pi over 4 is a unit circle one. So they finished it off and said, haha, square root of 2 over 2. This one was like a lot that we did in class. And I think, Robbie, you were helping me out a lot with these in the sense of when we did our sign is not with or together. These guys are unit circle. Plug them in, plug them in. 76 said use your calculator. You're like, cool. I'll graph them and then I'll find the zeros. There's one. There's one. There's one. 0, pi, 2 pi. Oh, sorry. There we go. We got it. All right, cool kids. Listening to my advice that word problems are not the main emphasis. Do we have any questions on 5.3 or 5.4 that you're like, yeah, especially the odds, the ones you tried, you graded with Calc Chat and you still didn't know how to do? Any big question marks as we were grading that we passed over? Tony. Number 67. And 5.3 questions especially are pretty important because isn't 5.3 used in 5.4 and 5.5? So yeah. I'm looking at the directions before I totally get rid of them. Use inverse functions to find all possible between 0 and 2 pi. Tony, look at that interval. Is that closed at 0? Okay. 0 and 2 pi. What do you guys think of as soon as you see something like this? It has a squared, good, which might point us to Pythagorean, right? But then shouldn't you also be thinking factor? Does that make sense? Okay. So Pythagorean, Tony, I would have done 1 minus cosine squared because sine squared and cosine doesn't match. I would have gotten 2 minus 2 cosine squared. I don't know about you guys, but I just really dislike having negatives in front of my squared term. What do you guys think? You don't like them either? So I'm going to move everybody to this side. That way I get a nice positive 2 cosine squared. Sure, that'll be a negative. And then I have 4 minus 2, which is 2. If you do the grouping method, A times C, adding to be B, I think a negative 4 and a negative 1. So I have negative 4 cosine, negative 1 cosine. At which point, with grouping, I believe you end up eventually getting 2 cosine of x minus 1 after factoring out and getting cosine of x minus 2. Does anybody agree with that? That's right. At which point, remember, Tony, we're looking for both possible solutions. So does cosine equal 1/2? 1, 2, 3, 3, 2, 1. That's going to be at pi over 3. I think it said 0 to 2 pi. That's also in the 4th quadrant, so 5 pi over 3. Cosine's positive in both of those. But remember, we also have, wait a minute, can cosine equal 2? Can I do cosine inverse of 2? Square root of 3 over 3. No, it's tangent, and that doesn't have 2 anyway. 0, 1/2, that's sine. 0, square root of 3 over 2, square root of 2 over 2, 1/2, and 1. Although the 0 and 1 should have been switched. None of those are 2. Oh, wait. What's the domain of cosine inverse, or how high, how low can cosine go? So this is what we would call, I think you brought this up, extraneous. So the only solutions are these guys. Kiddos, main goal for Monday. Formulas memorized. Come with as many questions of what you were able to attempt as possible. Cool? Cool. All right, I'll see you guys later. Stay warm, especially if you're out in the cold today helping with boards or whatnot. Especially if you go to HPrecalc tonight, which you should do because it's super fun. Please stay warm and healthy. Bye, guys.